Day 223 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem, and today we have question number 61, rotate list. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand as possible, so let's get into it. The question says, given the head of a linked list, rotate the list to the right by k places. So let's look at example one. It's pretty self-explanatory, but let's go through these examples anyway, just in case anybody needs help. So in example one, we have the input head equals a list of nodes 1, 2, 3, 4, and 5, and k equals 2. So that means we have to rotate this list of nodes by 2, right? So the first rotation, let's look at these pictures. The first rotation, we're going to move the 5 over here, and the 5 is going to be the new head. The 5 pointer is going to point to the 1, then the 1 pointer points to the 2 pointer points to the 3, and so on. The 3 pointer points to the 4. But since k equals 2, we need to repeat that one more time. So now the 4 becomes the head node, and then the 4 points to the 5 again. Then the 5 now points to the 1 points to the 2, and the 2 points to the 3. So what we did is we just rotated the list of the list nodes by 2, right? We did it 1 right here, put the 5 right here, boom, or we put the 5 right here, excuse me. Then we did it one more time to make it 2 times total, and we put the 4 right here. So the 4, this 4 and the 5 ends up being the head. The head starts with 4 instead of the tail. The 4 and the 5, which were the 2 end tails of the list node, now become the 2 heads of the list node, right? So let's look at example 2 one more for another example where it might be a little tricky, where this time k is greater than the number of nodes that we have altogether, right? So in example 2, we have the input head equals the list nodes 0, 1, and 2. This time k equals 4. That means we need to do 4 rotations, right? So we're starting like this. So we have 0, 1, and 2. So first we move the 2 over here. Boom. So now we have 2, 0, 1. That's one rotation. Then we have to do a second rotation. So we move the 1 to the head of the head node. So now it goes 1, 2, 0. But we're not done yet. We have a third rotation we have to do as well. So we do that again. So now the 0, now we're back at the original node, right? Boom, like that. And it goes 0, 1, 2. But we need 4 rotations because k equals 4, so we have to do it one more time. And now 2 is at the head of the node, and it goes 2, 0, 1. That's why the output is list node 2, 0, 1. We're just taking the last node and moving it to the front, and we're repeating that process however k amount of times. Whatever k is, whatever k is, that's how many times we have to repeat that process, y'all. So we're just rotating the list, moving every node that's in the back to the front as many times as k tells us we have to. So now that we understand the question, let's get into the solution. But before we get into the solution, if y'all need any new Apple AirPods, go ahead and check that link out in the description. After you do that, go ahead and like, comment, and subscribe. Now, let's get into the solution. Solution's not that difficult, y'all. First thing we're going to do is we're going to check if the list is empty or contains only one node. In such case, then the rotation will be unnecessary. So we're not going to need to rotate anything if the list is empty or contains one node. And we are going to check that by using a guard statement, and by saying guard head question mark dot next exclamation point equal sign. So guard head question mark dot next does not equal nil, else we are going to return head. Boom, just like that. Then we're going to come down here. So first, let me explain this. We're going to make sure that there is a next, right? If there is no, so we have the head, right? That means we have one node already. If we have the head, and the head is optional, so it may or may not be there for if it's empty or not. So if there is no next after the head, meaning it is nil, then we're going to return the head. But if it's not nil, then we're just going to keep going with the rest of the code. And for the rest of the code, now we need to create 2 variables that are going to traverse the list and And we're going to need a counter to calculate the length of the list, right? So first thing we're going to do, we're going to declare a variable called cur, and we are going to set that equal to head. Then we're going to declare another variable called length for length, and we are going to set that equal to 1 just to start out. We'll mutate those if we need to later on. So now it's time to traverse the list to find its length and the tail node, right? So the tail node is the last node, so we're going to have to traverse the list to see how many nodes there are and how many, which is going to help us when we're rotating, right? So we're going to say while cur question mark dot next does not equal nil. So once again, while there's a node after the next, while there's a node after the current node, right? So as long as it's not nil, then we're going to say cur. We're going to set cur to cur question mark dot next. As long as there's something to set it to, we're going to keep looping through this or traversing through this list, and we're going to increment len because that's going to tell us right now len is at 1. But each time we go to the next node, we're going to increment len to help us keep count of how many nodes there actually are. And this should be len plus equals 1. Sorry about that. But that's going to keep count of each new node that we see to keep us which will give us the final count in the end of how many nodes there are. Then we're going to come down here and we are going to connect the tail node to the head node, which is going to form something like a circular list, which is going to help with the rotating, right? So when you rotate, it's going to be easier to rotate if it's a circle, you know what I'm saying? If you could just imagine a circle and you're rotating it, right? So we're going to, so now, oops, sorry, y'all. So now we're going to connect the tail to the head, which is going to form a circular linked list. And to do that, we're just going to say cur question mark dot next equals head. Boom. So whatever is the last node, right? Because we're already doing this till we get to nil. So once we get to the tail node, we're just going to connect that to the head, and that's going to create like a circular linked list for us. Now what we need to do is we need to calculate the number of rotations that we need, and we can do this. Well, I'll show you how we can do this, but we can do this by finding doing calling k mod len, right? And then subtracting it. So let me show you how we're going to do that. We're going to say for underscore in 0 up to, open up the parentheses, we're going to say len minus k mod len. Excuse me. Then we're going to come outside of that, open up the brackets. And what that is going to do, that's going to help us calculate the number of rotations we need, right? So we only need this in order to calculate to find the rotations, right? But then we need to subtract this from the length in order to determine the new tail position after the rotation, right? So we're going to have to find a new tail. There will be a new tail after each rotation, and that's why we're subtracting it from the length. So we'll know what the new tail will be. Then what we're going to do is we are going to say cur equals cur question mark dot next, and all that's going to do is it's going to move the cur pointer, the current pointer, to the new tail position. Then we're going to come underneath that and we are going to declare a variable called new head, and we're going to set that equal to cur question mark dot next. And what that is going to do is the new head will be the node following the new tail, because we're rotating it, right? So remember, if this is the tail and we move the tail over here, so now the tail is the new head, right? So this would be the new head, and this right here, the 3 would be the new tail because we moved the 4 over here, and the 3 would now be the tail, and the 4 would be the new head. Then we still have to remember we have it in a circular linked list, so we have to break the circular linked list, and in order to break the circular linked list that we've been doing, all we have to do is say cur question mark dot next equals nil. So now that's going to break the circular list, because now after this, right, say 3 is the tail, now after the next after the tail would be nil, right? It's not going to be 4. Right now, this 3 will point to the 4, but now it's going to just be nil after that, and that's going to remove the pointer to 4 and break the circular list that we have created. And then all we have to do is say return new head, just like that, y'all. So let's run it. Make sure it runs how it's supposed to run. Let's see. And look at that, it's accepted, y'all. So let's submit it. Make sure it stays accepted. Let's see. Oh yeah, 0 milliseconds beats 100% of users with Swift. That's what I like to see. That's faster than y'all. That's faster than a Bugatti riding past Andrew Tate and the rest of the brokies down the highway, y'all. That's what I like to see. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. Oh yeah, before we leave though, y'all get one more look at the code. If y'all need to get one more look at the code, get one more look at it. Read it, learn it, love it. And I'll see y'all here tomorrow for another day, another LeetCode problem. See y'all then.